in security for a long time. And about 7, 8 months ago, I started working on Linux. And that's what I'm here to talk about. So I'll just go. So here's the plan. I'm not going to be talking too much because I'm actually almost lost my voice. So you guys won't have to worry too much about that. But so we'll just start talking about Azure App Service first. How many people here actually use Azure App Services? No, very familiar with it. It's less than half of you. So I think it's probably worthwhile just to talk about what the hell Azure App Service actually is. So we'll just start with that. And we'll just talk about why on earth we're doing Linux work for Azure App Service. How does it work? And then we'll just dig a little deeper. And then I'm going to just give you guys tons of time to ask questions. So whatever you guys want to know, I'll show you. Even if it's not just Linux related, if you want to just know about regular Azure App Services stuff, I'd be happy to show you some of that stuff too. All right? So what exactly is Azure App Service, right? I have a bunch of points here, but the main thing to realize is in the cloud, there's like a gradient of things, right? So you start at one end from what we call IaaS, and at the other end you have what's called SaaS, and in the middle you have this thing called PaaS. What does all this stuff mean, right? So IaaS is infrastructure as a service, where basically essentially all you get is VMs. You get bare bone things, and you're responsible for managing everything yourself, including updates and application level, and even the platform level, right? And the other end of the spectrum is SaaS, where essentially you don't care anything about what's underneath the covers. All you get is an application. Think about things like Office 365, Salesforce. All of those are sort of like in the SaaS end of the spectrum. But if you're developing your own application, but you really don't care about managing all the infrastructure below it yourself, all you really care about is your app. What you really want is PaaS, which stands for Platform as a Service. It's also called managed frameworks. So by managed, they basically mean that we manage things for you, so you don't ever have to worry about patching VMs or VMs at all, right? All you care about is the application. You deploy it. It seamlessly scales up and down. You can write auto-scale rules, and that's sort of what PaaS is about. And what Azure App Services is, it's a PaaS platform. So it's a fully managed platform for you to write web applications, APIs, mobile apps, you name it, right? That's what we do. The main takeaway here is it's fully managed, right? And we have the DevOps folks' best interest at heart. So we really have a lot of really cool DevOps features, and we'll get into some of those as we carry on. So as I was saying, it's just one offering that basically we use to just do a bunch of stuff. You can do web apps, mobile apps, and a bunch of different things. And I'm not sure how many people have heard about functions before. You guys heard about functions. The functions is a new thing. It's about serverless compute. So think about things like, even for PaaS, for a managed solution, you basically tell us, okay, you know what, my app needs X amount of resources, right? And sure, we make it easy for you to scale up and down and even have auto-scale rules. So you can basically say things like, hey, if my CPU on my compute underneath the covers goes above 80%, or my HTTP request queue length goes over a certain limit, I want you to scale up. And the reverse as well. I want you to scale down when the traffic goes down. That way you just save some money, right? But with serverless, the basic premise is you don't care. You have a function or basically some piece of code that you want to execute. And then we take care of everything depending on how many hits you get, right? If you're getting very few hits, we'll make sure that you're just going to off in a really small corner. And all you really pay is for each function execution. You don't pay for compute at all, right? So if your API gets called once in 1 year, I don't know what your bill will be, but it's probably going to be 0, right? So all you pay is per call to function. So why Linux in this whole thing, right? So basically, we had all this stuff running on Windows, obviously, because we're pretty much a Windows shop, right, in Microsoft. But we had a couple of things that we had to take care of, right? The first thing is really, this is what our customers were asking us for, right? 1 of every 3, even IaaS VMs in Azure is Linux. And this number actually is growing faster than our Windows VMs, right? So that should be a clear sign to us that customers want Linux, so we need to give them, right? And right now in Azure, we really don't have any fully managed Linux-based platform, right? And then the key here is fully managed. Sure, we have things like Service Fabric on Linux, but those are not fully managed. You still need to take care of patching your, the VMs underneath the cover. If Service Fabric version changes, you need to take care of rollover and things of that nature. But this is what we're going to offer is fully managed, right? if you go, we listen pretty carefully on user-wise, so our forums, and this is one of our top asks, people want Linux, right? And of course, it's a huge business opportunity for us, right? With all the customers that we have still not yet tapped. The other thing really is supportability, right? Customers already have applications. They want to make sure that those applications work seamlessly on our platform. And at the same time, they don't want to run the stuff on VMs. It's a big hassle running stuff on VMs, right? Especially think about it like a small shop, like just you and your friend. You just started a company, a consulting company, and you make applications for a bunch of customers, right? If it's just two of you, you really want to focus on the apps you write. You don't want to focus on maintaining all these customers' infrastructure, right? Because as you keep growing your customer base, that will force you to hire more and more people. So what that basically means is, hey, this application frameworks of PHP, Node.js, Ruby on Rails, and a bunch of other stuff. Do these work, right? For the most part, a lot of the stuff just works on Windows, right? So we have PHP, we have Node.js, we have Java, all this stuff works on Windows. But the problem that happens is there's all these oddball extensions and stuff like that people just really don't keep Windows in mind. Like if you go to PHP, for example, they tell you exactly how to write extensions for PHP. Nobody follows those rules, right? Nobody thinks about portability or any of that stuff. They just get it working for basically just get it working for Linux, and Windows sometimes is just an afterthought. And especially this is true when it comes to new frameworks like Meteor.js and stuff like that. Just Windows is typically just an afterthought, right? So what we really need to do is we need to have sort of cutting-edge framework support that people and customers are already using right now working against our platform, which basically entails you need to get Linux working, right? The other thing is it's really about embracing change, right? I mean, Microsoft has kind of gone out in the last 2 years since Satya has taken over and said, Microsoft loves Linux. We are part of a pretty big part of the Linux Foundation. I know that later this year, Microsoft is going to be announcing its own distro of Linux as well. And if you go look over the last 4 or 5 years, Microsoft actually has been the #1 contributor to the Linux kernel. There's a reason why Linus does a lot of photo ops and stuff at Microsoft, because we really are one of the largest contributors to the Linux kernel at this point. So, there's this perception as well. And one of the things is we have a great product on Windows, and we just want to show also that we can actually have a great product for Linux as well, right? The other thing here is that there has been some sort of paradigm shift. A lot of people, microservices is the new buzzword, right? Everyone wants to do microservices. Even people who don't really know what the hell microservices are, they still want to do microservices because that's the new buzzword. And the interesting thing over here is that a lot of the microservices developers, they will choose some sort of platform abstraction to sort of compartmentalize their application and sort of break it into bits, what you call microservices, and then connect them together. And one of the things that customers have already chosen to do this compartmentalization is use Docker, right? So they use Docker images. So there's a lot of the stuff that people are already doing that we need to make sure that we adapt to so that we can offer the same sort of development model for our customers as well, right? Wouldn't it be cool if you actually could use Docker images and then compose an app that's fully managed, right? I don't want to stand up my own Kubernetes stamp or Mesosphere or whatever, and then have that deal with Mesosphere or Kubernetes config. It's too complicated for most people, right? For most people, it's just like, hey, I have a Docker image, right? It's got my app built in it. That's it. Just give me a place to go run this. That'll just scale automatically, as with sort of like traffic and things of that nature. That's all really people care about. And so one of the things that we want to do is we want to sort of essentially ride on that momentum too, right? So I wasn't kidding. I'm just going to start immediately with demos, right? So let's just see what we have at this point. Go minimize this. Sorry, I had some networking issues. I'm still on Wi-Fi at this point. Hopefully things to keep working well. Connection error. All right, it's going to reload the portal. So basically, for the people who haven't used Azure App Services before, or even Azure before, this is the main management portal. You just go to portal.azure.com, and it's pretty fast and simple to create web applications, right? Just with a few clicks of a button. So I'm just going to go new, and yes, the Wi-Fi is really slow. Anytime now. Wow. It's still loading. Wow, new showed up. There you go. New web and mobile. Now this is going to take some time to show up. God, now it's going to update something. All right. So this is web app on Linux right here. That's in preview. And all you really need to do is give it a name. Hello Ignite New Zealand. Okay, and choose a subscription you want. Let's choose that. And I'm going to go choose a stack. And you can kind of see that we already have PHP and Node.js built in right now. As you can imagine, we went public preview just 2 weeks ago. So we're just going to keep adding stuff to this, right? This is not the only list you're going to see. And we're working on this at a pretty rapid pace. So you can just expect to see new application frameworks showing up very, very fast. We have some infrastructure work that we need to do to make this a really seamless process. And I'll talk about that later on towards the end of the talk when we just kind of dive into a little bit of the details. So it's deploying the app right now. Oops, let's keep seeing this. So right now, we have this in 3 regions. We have it in West US, we have it in Southeast Asia, and we have it in West Europe, right? Of course, we have data centers in Australia and a whole bunch of other places. Because we're just in preview, we don't have that much demand. As we get more demand, essentially we just kind of make sure that we spread out, right? Naturally into more regions. So there's my site. I created it on a Node site. So let me just go click on the URL here, and it'll just load this up for me. Now you kind of notice that I didn't really deploy anything here. I just created an app, and I got a little interesting hello world page, and okay, and it's just telling me, yeah, there's really nothing much here, right, to see. So I'm going to go back here, and I'm going to go to something called the SCM site. Now, what really is this SCM site? If I just click on go here, you'll see that this site is exactly my site name, but this little SCM thing in the middle. And what SCM really is sort of like Service Control Manager. So it gives me ability to interact with my application and do things from the portal itself. And one of the things that you notice that it's directly gone into login.microsoftonline.com here. And what that's done is it's actually single signed me on. Because I'm already logged into the Azure Management Portal, it uses the same credentials as the Management Portal to single sign me on over here, right? And you can essentially see a bunch of stuff here. You can see sort of like what environment you're running in, which has a whole bunch of stuff. So I wasn't lying. We actually are running on Linux, and that's the kernel version right there, and a whole bunch of environment variables and HTTP headers and all that kind of stuff, right? But the interesting thing here is that we do give you a little bash console right here to kind of see what you can really do in your app, right? So in my app, I have a site www.root folder. And if I just enumerate all the stuff in here, you can kind of see I have a bunch of stuff already running in here. And so, I created a site. It seems like an empty site. It seems to be working. But at this point, I realized, crap, I chose Node.js. I really didn't want to do that. Right? I want a PHP app instead, right? So I'm just going to go create a PHP info file over here. So let me just go do and say echo. Make sure that I make the syntax right here. PHP info, not info. PHP info. That looks correct. I'm going to pipe it out to PHP info.php. Okay. See, it's there. Cat it out. Make sure it looks correct. It looks correct. Okay, sweet. But this is a Node.js app, right? I need to just switch it back to PHP. So let's just go do that really quickly. It's not very hard. So I'm just going to go back to my web app that I created really quickly over here. And underneath over here, once it loads up, you should see something called application settings. It's right here. And in application settings, once this loads up, essentially this location shows you all the different options for your application, right? So it shows you, hey, I'm running PHP. This is a version of PHP that I'm running. Oh, actually, I chose a PHP one, not Node.js. My bad. Okay, I was actually going to show you Node.js and then switch to PHP. I goofed up. Anyways, this is PHP already, so this should be like a no-brainer, right? I just literally just go to the website and do phpinfo.php, and that should just work. Okay, that was not very exciting. Sorry, guys. So let's just go and actually switch this thing to something else now, right? So let me just go turn PHP off. And let's just go move to Node.js 4.5, all right? And it immediately gives me this thing called Node.js startup file. And if you guys have done Node.js development before, you kind of know that, hey, I need to let Node know what sort of my startup script is, right? But instead of giving a startup script, I'm going to give something very different here, right? So I'm going to give something called process.json. And I'm going to just get into a little bit what the hell process.json actually is. So I'm going to save this. Now, the other interesting thing is, I'm not going to go to the SCM site and echo out a bunch of stuff to get my application deployed. That's not how people do it, right? Most people, the way they deploy apps is through something like a source control manager, like GitHub or local Git deployment, right? So let's just go, and for this app, let's just set up like a GitHub deployment, right? So I'm going to close this guy. Jeez, I want to close the whole thing. And scroll down here to deployment options when it shows up. So here's deployment options. And I've already logged into GitHub before, so it's like right here somewhere. There you go. Yeah, it's already logged in. So it shouldn't really ask me to log in. So once I choose GitHub, and you can kind of see for people who already used app services before, you kind of see the list is a little bit sparse. It just shows like local Git and GitHub. We actually have a bunch of other stuff working, but we haven't thoroughly tested it. So you'll see a lot of stuff that doesn't show up in the UX here, and there's a reason for it. The main reason is that we kind of know it works, but it's not really there up to quality. So we don't want customers to try this out. Even though we say it's preview, there's no SLA, but we don't want just customers to get frustrated, right? So we're just going to hide that stuff right now. So you got to see that I'm already logged in. I'm just going to choose a project. I'm going to choose this ImageMagick app really quick and click OK. And it's going to start setting up the deployment source at this point, right? So let's just quickly go and, it's already done, jeez, okay. So let's just quickly look what the hell ImageMagick app is. How many people here use Node.js, by the way? All right, you guys already know what the hell ImageMagick is, I'm sure, right? ImageMagick is a very, very popular image manipulation library, right? And it just comes as a node package, so all you go to do is you package a JSON file, and you basically say, hey, add a reference to ImageMagick, and you're off to the races. The big problem here is that ImageMagick actually is a native library on Linux. Now, this thing actually has been ported to Windows, but it's horrible. The port is absolutely horrendous. It just does not work, right? And even though this is like one of the most popular packages for Node, the fact that it doesn't work on Windows is a big problem. So I said, you know what? This is the ideal app to kind of show off that, hey, this stuff is all working on Linux. And this is one of the issues that our customers will hit as well, right? They don't really care about what's running under the covers. They have an app. It uses ImageMagick. It just needs to work, right? So let's just go back to our diagnostic console here and list out what's in our site. You can automatically see I have a bunch more stuff here now. So because I connected to GitHub, it just synced all my files automatically, right, at this point. So if I go back to my site, oh, sorry. I need to go change something really quick. I need to go and change this to using, let me go to application settings. And let me change my Node version really quick. Because I'm not really a Node developer, and I really suck at this. So I think I really messed up my, and let me just go delete this guy as well. I don't really want a default Node version here at all. Oh, actually, this is a way to delete it, isn't it? Delete. There you go. Delete, change to 6.6, save. All right. So I'm just going to quickly switch to 6.6 version of Node. And while it's doing that here, let me just go and start up the site again over here. And you can kind of see that it's kind of get the service unavailable thing coming for a little while. And this is essentially in Windows as well. What happens is that whenever you restart your site, you make some application change, what happens is that we need to restart your worker process, right? In this case, we need to do the same thing. But in Windows, we have this interesting feature called overlap recycle, which basically what it does is it starts a new worker process. It starts redirecting traffic to the new guy, and it lets the old one drain all the requests that are in flight, correct? Now, we don't have that working yet. So it's not very hard. We almost have some code working for the stuff. So maybe in the next couple of weeks, we'll probably have this stuff working. But for right now, it kind of looks awkward. Every time you recycle your worker process, you kind of see this like bizarre error. But there you go. Now my app is working, right? So what does this really do? And remember, like in the beginning, we set the startup script to process.json. What the hell was that about? So let's just go here and see what that process.json file is. So if you look at this process.json file, all this is, if you folks who are familiar with Node, is that there's a bunch of different process managers for Node. One of the common process managers that people use is something called PM2. This actually is the PM2 process config file, right? What it basically tells you is, hey, what's my startup script? It's server.js. How many instances of this Node process do I want to spawn? right? I'm actually running on a large VM. So it doesn't make sense for me to spawn one node process. Just might as well go ahead and spawn 4. Here's my log format. Here's the files I want to watch change notifications for, right? So anytime any of these files change, please go recycle my node processes, right? Otherwise, you won't see the changes. And the other options that I have here is, just like how do I want to do these change notifications? And you kind of see that right now, you have to use this thing called polling, right? And the reason you have to use polling, and we will get into this a little bit later on, is that the way your content shows up, it's getting mounted in via an SMB share, correct? And because you have an SMB share mounted here, you really can't do sort of like the standard change notifications. You had to do something like polling, right? So you can just tinker around with this, and that's all really this is, right? This is sort of your PM2 process management config. So here's my little app, and so let's go and see, make sure it works. Okay, let me just go get myself a little GIF. That looks good. Please work. And let it go do its thing. Oh, it's already done. Sweet. So there's image magic. It actually works, unlike how it would be on Windows. So there you go, success. So that's pretty cool, right? And then we have a bunch of other options, right? You can actually go set up custom domains. We already have scale out options that you can do here, and a bunch of other stuff that we can come back later if people want to just go talk about this, right? And there's a whole bunch of diagnostic logs, and you can look at the logs here. So one of the things over here that I want to just point out, if you go to diagnostic logs, you usually have a switch to turn it on and off, and you're going to see that everything's off here, but because we are in preview, we just don't care about what you set it as. We will always do diagnostic logging for you. So if you actually go to your SCM site, for example, and you go up, did I lose focus? I did, okay. If you go up a couple of levels, you will see this log files directory. Oh my God, why do I keep losing focus? Okay. And in here, you'll see there's a whole bunch of log files, right? And you can kind of see there's a worker error.log and worker out.log, and that's just a standard error and standard out from the node process, right? So if you just go do cat worker out.log, you kind of see, hey, look at this, it's like worker output. You can kind of see that it's going and reading my GIF file. It interpreted, it just did all the image magic work and wrote down a file called messyreading.gif, and that's what it's rendering for me, right? So all the log file stuff is just working. And if some people noticed, there's a little Docker log here, and everyone's like, what the hell is that? We'll come to that in a little while. So there you go. There's like, most of the stuff is already working. So that was interesting, right? But how does this stuff really work under the covers, right? So if you just, okay. So the 10,000 foot view is something like this, right? You essentially have a virtual network, and then you have these two compute clusters in there. And one is essentially what we call our primary cloud service. And this has things like our front-end load balancers and a whole bunch of other stuff, right? It even has things like these Windows workers that do your Windows applications, right? Stuff like that. And what we do is we stand up the secondary cluster of compute on which all we really have are all these Linux VMs, right? And what Linux do we have? We actually use Ubuntu 16.04 right now. And because we're still in preview and we don't have to worry about breaking too many customers, we're very aggressive with patching this stuff, right? So if you guys are keeping up to date with Linux stuff, you probably heard about the copy on write issue that just, I don't know, it was maybe like 4 days ago. And then there was the system D vulnerability that released, that was discovered 2 weeks ago. Both of those are already patched for us, right? So we're pretty aggressive about patching our stuff. Most of the other guys are not even patched, right? I don't think Heroku is patched yet with the copy and write vulnerability, so we're pretty aggressive with this stuff. But what does it really look like on the Linux VM itself, right? So ignore the Apache plus PHP thing. It's really just an Apache proxying module. So what happens is that when you get a request that comes in to essentially your VM, we need to figure out what site it goes to, right? Because in the way this works in Azure App Service is that when we created this app service, I created something called an app service plan. Your app service plan is essentially a container it's essentially your resource container. It tells you how many resources you have for your applications. Now inside this app service plan, I can create one app, I can create 1,000 apps. Doesn't matter, we're not gonna stop you, right? But all those apps run within the same pool of resources. So I can go and say, hey, create an app service plan for me with 5 large VMs. And in these large 5 VMs now I can put how many apps I want, correct? So this could be one of those large 5 VMs. And if you had 20 apps, all your 20 apps would be on this VM. So we need to know which application do I reroute this request to, right? And that's what the proxying logic does. The other thing is like there's a site routing component to this that basically says, hey, if I get a request coming in for foo.com, right, and you guys created a foo.com, what do I need to start up foo.com? The interesting thing here is that your application and the SCM site both run as a Docker container, right? And your content right now sits on a file share, so it's mounted via SMB into these Docker containers, which is why we had this whole watch file issues thing where we had to use instead of using change notifications, you had to use polling to do this, right? And so essentially all the site routing guy does is it basically says, okay, this foo.com, it uses Node.js version 6.6, so I need to get the right Node.js 6.6 image down. I'm going to do a Docker pull, start running the container. I'm going to mount the SMB share in there, and voila, you have the stuff working, right? And because we are mounting an SMB share here, we mount the same SMB share both into the Docker container. Oh, you guys can't see, but into the Docker container above, and the SCM in the app container and the SCM container. So same application code in both those containers. And if you're running multiple instances, like if you have 5 instances of this app, it's the same SMB share. So when you write to it, it's persistent across all instances, right? So you don't have to worry about sort of persisting the stuff, your content, making changes. This is why even GitHub deployment works, right? So your GitHub deployment or your local Git deployment goes directly against the content, which is on this file share. So once you push a change, that gets reflected everywhere. All instances of your apps, you don't have to worry about anything, right? And then tomorrow you say, geez, I'm paying a lot of money for 5 VMs, and you just click one button that says scale down to 1. Or you can have an auto scale rule that says, hey, if I don't see, if my CPU is like 20% or below, just keep scaling down. So you can have auto scale rules, right, to scale back down. So that's sort of how this thing works. But now a bunch of you guys are like thinking here, what the hell? These guys use Docker images below. You've got to be able to do a little bit more than what they've done right now. That's true, and as I was saying before, we don't show everything in the UI yet because we're working pretty aggressively. We have a very small team. It's just like 4 people, including me, that work on the stuff. And so we just go make changes extremely aggressively. And we don't go and advertise a lot of these changes unless we really know that, make sure that customers are not going to get frustrated, right? So because you have Docker running, I should be able to do some pretty cool stuff, right? So you kind of saw that in the portal. All I really showed you was when you created a new app, I didn't get too many options, right? It just told me you got like 3 or 4 versions of PHP and a couple of versions of Node.js, right? But man, I just don't use either one of them, right? I'm a Ruby on Rails guy. That's really what I use. But you guys use Docker behind the covers. Shouldn't I just be able to just give you some sort of Docker image and just get this working? Well, actually, you can, right? So let me just go quickly switch over. And can you guys read this okay? Looks okay? All right. All right. Oh, shoot. Yeah, you know what? I really should go shut this out. I did quiet hours, but it's still just Skype, man. All right, whatever. Jeez. Okay. So here's a Ruby Hello World app, right? And all you can see here, it's pretty simple. So let me just go show you what the app looks like. And that's all it is, right? If you guys have done Ruby before, Puma is a concurrent web server that Ruby has, and Rack is a very simple, lightweight web application framework. So all I did was I just wrote a script that uses Rack, and all it does is hello world, right? So let's go and change this really quick. Oh, I can't spell it right. All right. Save this guy, and let's just go. If you see over here, I actually have Docker running on Windows. For you guys who didn't know about this, yeah, Docker runs on Windows, but it's kind of like cheating. What it does is it actually spawns a VM that's running Ubuntu on your machine, and then just redirects everything here. So if you actually go launch Hyper-V, for instance, you'll kind of see that it has, where to go? Oh, there. can see that it has this VM running, and it's essentially running Ubuntu VM on there, and that's how it does Docker, right? But there you go. So I have Docker, and what we're going to do is I'm going to build a new image. So jeez, I can't type today. So Docker build, and I'm going to give it a tag, nazml/ruby hello, and let's version it as 0.2. Okay? Ah, didn't like that. Nazml ruby hello. Oh, sorry, local directory. Okay, so it's going building this thing, and so if you see what's happened here is that I've actually done a Docker login. So I'm actually logged into Docker Hub as well. So I have a little Docker Hub account, and you can kind of see that this is my stuff, and I have a 0.1 version, and I built a 0.2. So this one's really weird. Like the APIs on Docker Hub, they're extremely laggy for some reason. I'm not sure if you guys hit this, but I couldn't find a way around this. It's actually already built, but I don't see like the Docker APIs will like not show it for another like 10 minutes, even though actually it is available. It's not immediately available, but it is. But if I just keep doing this, it's waiting for Docker Hub. Yeah, it still doesn't show, but trust me, I think it's there. So let me go to my portal, close the sky, and what I'm going to do, so because I don't really have a good portal experience for this, the way we hack up a lot of these new features is by these things called app settings. So you probably saw this thing that I was touching before, this thing called application settings. And if you guys haven't used, so if you guys have used Windows before, you know that we give you some pretty crazy advanced options like local caching and all this weird stuff that lets you customize how your application behaves by these key value pairs down here called app settings. So what we've done here is that you can kind of see that this app right here, actually it has like Node.js version set, but all this stuff is ignored. As soon as you set this one app setting called Docker custom image name, and let's just go change this. So right now, actually, hold on, before I do anything, let me just go make sure this site actually works. It's been a while since I've created the site, so I have no idea right now. Let's go look at the stuff. It's a hello world. Okay, it still works. Good. Now let's go back to app settings. And let's just go change that guy that we had down here. And let's just go use that new image that we pushed. It was 0.2. Geez, I can't remember what I did. I think it was 0.2. All right. So I'm going to go update this app setting. Is it done yet? Okay, it's done. Again, once I go here to that app, did I close the window again? I did. Jeez. All right, let's go back here and go launch this guy. And so now what it's doing at this point is that, oh, did I break it? It's the image caching thing. It's just the API, it's not updated yet. It's probably still not showing up here. Even though I pushed, is it showing up here? Yeah, it's very bizarre. I hate this fact that the API is still like lagging behind what we actually push up to the image repository for Docker. So let's just give it another shot. Maybe it's able to connect. But essentially, at this point, what it's trying to do is that, let me go back up here. So, geez, what happened? Okay. So you see this site routing component. Essentially, what it's doing is when you selected Node 6.6, it basically said, OK, I want to use a Node 6.6 image. So it went and did a Docker pull, got a Node 6.6 image, and injected all the stuff in and got it working. When I injected this new app setting in it, all it basically said was, hey, this guy doesn't want to use Node 6.6 or 4.5. He wants to use something completely different. So what it goes instead and does is it goes and does a Docker pull. Now again, Docker pull can be pretty large. So like some of these things, the images are like 600, 700 megabytes large. So it's going to pull all the things. So it might take a little while to pull some of the stuff as well. So you might want to do something like an application warm up before. So it just pulls all the stuff down first. And then it just does the same thing that it does always before. But most people, when they actually go build Docker images, they don't expect their content to be somewhere separate that then you go to git deploy, right? Typically, just bake their application right into the image itself, which is what I have done, right? So like when I did the Docker build, you probably noticed that this is the wrong Docker file. Let me just go to the right one. I if I go back to Ruby hello world, here's the Docker file. You kind of see that I just actually grab whatever is locally on this guy and shove it in, right? And in a directory called app, and that's what I'm using. So I'm just like copying all the files locally, and the files, there's not much, right? There's just literally one just Ruby file here. So let's just go back, see if Docker Hub is happy. Docker Hub is really not happy. Huh? Oh, it's still seeing slides. Oh my God, I forgot. Here, I actually have to go to escape. And now I should be able to go. Let's try something really quick. Let's just go and first let's check that the setting is correct. Okay. Oh, where'd it go? Nazimel, Ruby hello, correct one. Let's go change this to 0.1 because it's an older version, correct? And click save. Let it update its thing. Since this one's already there on Docker Hub, it should have been up there for a while. There's an 0.1 image already there. If I go here, okay, that one works. Jeez. So you can take my word for it. Ruby is working. I have a custom image, and it's already working with Ruby. Just that Docker Hub doesn't find it very happy for me with 0.2 image. It thinks it's not done. Save again. Switch to 0.2. And let me just quickly go and actually check. Actually, wait a minute. I want to make sure that I didn't have any error. Successfully built. Docker images. And oh my God, I'm an idiot. Okay, sorry guys. Shit, I forgot to push. Okay. All right, no wonder it wasn't working. I was blaming this on Docker Hub. It's really my own fault. All right, now I actually push this thing to Docker Hub, and hopefully it shows up. So there you go. It's pushing the image at this point. And you can see that, like Docker, if you guys are not familiar with Docker, Docker is like sort of built on layers. So you kind of see that it actually, the push happened really fast. Even though the image is like, whatever, 400 megs, it had to push very little content because I had something, the diff that I made was very small. So it only had to push the diff, right, which is pretty cool. So now I actually have 0.2 up there. And this might lag a little bit still. So let's just do one thing really quick. So go back here. Let's go switch to 0.1. Make sure it's working. It's going to do its thing. And this shouldn't really take any time at all. It should come up pretty fast. And the reason oh, it worked. What the hell? Why did it pull 0.2? Oh my God. It's like it's like magic. What? Control F5? Okay. I don't know how that worked, but okay. That did work. So even though I changed to 0.1, I think my application settings and somehow I just like really ended up confusing the little site routing logic that I had. But you can kind of see that I built a new app. I got it, customized it, and sent it, and boom, it actually just works, right? So it's pretty cool. So that's what we have working right now. We'll just polish it up a little bit more before we show it in the portal. We'll add a few more things. We're not going to ask you to set like app settings with Docker custom image name and stuff like that, right? We'll make it much more pleasant for you, the experience. We'll even do things like auto discovery and validation. So if you have a typo in your image name, you don't want to fail like much later on. But the cool thing is, actually, I completely forgot. So one of the things that we did, we should figure out why this thing, like what the hell happened here? Why did it work really bizarre? So we can actually go to the kudu site for this guy. Again, the slides, yes. Thanks for reminding me, guys. Escape out of this. Eventually, we're going to make it a first-class citizen. So you'll kind of see it in a drop-down. People ask for Ruby, Python, Go, Java. They want everything, right? And so we will eventually have almost everything over there. But people also just have their own little flavors. Like, I want to use Node, but I want to use PM2. I have my own cool. Whatever it is, right? Oh, .NET Core is actually, oh shit. .NET Core is actually already working, but we hide that because So .NET Core, the reason we hit it was because of the whole RC versus RTM fiasco. How many guys have actually used .NET Core? It's blazingly fast, right? .NET Core on our stuff is amazing. Like those guys are going out crazy. And the cool thing was, I don't know if I have that image. Do you guys know about Alpine Linux? Alpine Linux is a version of Linux that's 30 megs. That's it. It's tiny. So I actually had a Docker image with Alpine Linux on it and .NET Core, the entire image with my app. So I had the entire bakery sample app in .NET Core, and the entire thing, the image size, I believe, was 41 megs. And it was actually working. So I don't know if I actually pushed that guy up somewhere or not, but that makes for a really, really cool demo as well. Do I have that? Jeez. No, this one's not using that. So I'll tell you sort of what the difference really is, right? And it's a good point. Like I'll get to that in a little bit. So first things first, let's just go back here to, this is the Ruby app. Let me just go to Kudu's site. Where did it go? Right there. Let's launch this guy. So one thing that's really cool, I know once you guys have seen this, even though we haven't enabled it in the portal yet, a bunch of you guys are going to play around with this stuff, and you guys are going to be very frustrated when things don't work. So let me just show this stuff to you. When the Kudu site comes up, remember the little Docker file that I was showing you in the log files directory? Those are all your Docker logs. So when your container fails to start up, or something goes really badly wrong, that's where you want to go look at things, right? So let's just go to the bash console really quick, and let me show you that this stuff actually works. Log files. So a directory called Docker. Yeah, don't worry about the log file name. A lot of you guys are like, what is that file name? This we've just kind of done for internal debugging purposes. Remember, like when you get a VM, right? And I basically said that I'd chosen for this guy, the app service plan was a large VM. This kind of gives us an instance ID of the VM. So when things go really bad on the back end, we can go log in. It gives us an idea of sort of what's going on, right? And I can see that there's a bunch of errors in here too, right? So let's just, oh God, I gotta type this thing out. Okay, I should have thought about this before. Dedicated, large, I don't have autocomplete working in this yet. I can do star, that's true. But I don't know, the other file looks pretty large. Yeah. Anyways, so you can kind of see that it's pull Ruby hello 0.2. It's got the SHA, and it's listening on port 8080 locally. So it kind of looks like it actually worked. Did it do Docker error first? Oh geez, there's so much stuff here. But anyways, yeah, so it seemed like that actually worked. I'll just work. So. Huh? Cat star what? Oh, I can do that too. Star, hold on. How's the file written as? Let me just go. Is it? It's lowercase. Okay, so cat star dot log. Okay, yeah, it's complaining about 0.2 not found. So that's what the errors were. Not surprising. So that time actually was lag in Docker Hub. That was causing the issues, unlike the first time when I forgot to push. So here's the caveat. So it's like somebody asked me a question like, let me just switch back here. So there's a couple of interesting things to note about using custom images. So when the node example that I showed you earlier on, where was the content for that sitting? The server JS file and everything? It was sitting here. It was an SMB share, right? It's probably going to be a performance impact. Sure, it makes it very easy that you have like these multiple instances of your site that are linked to the same content, and you do a git push one place, and everything just shows up magically. It's pretty cool from a DevOps perspective. It makes your life really easy from DevOps. But the problem there is that you do take a slight perfit, right? Because you have an SMB share. I'm mounting the SMB share in there into your containers. It takes a while for all this stuff to work, right? But this Ruby example that I did, because the application was built into the Docker image itself, when I did a Docker pull, the app was actually sitting on your local content directory. It was in the VM, right? It was just local. There's no SMB share. So that's actually going to run a lot faster too, right? But because your app is sitting on local, it doesn't really give you the ability to do GitHub and all that kind of stuff, cool integration. But here's the catch. Remember when I told you that I mount the site content, I inject it into this directory called /home into this container? I still do that for custom images, all right? So what does this mean? This means that even if your application is locally built into your Docker image, you still have a location that is shared across all instances of your app that you can use to just shove things, log files, whatever you want. Or if you're completely crazy and you say, okay, I want to use a Docker custom image, but not for my app. It's just like my base dependencies, right? You guys use some Ubuntu something. I don't want to use that OS. I want to use Alpine Linux because it's freaking 30 megs and it's awesome, right? So I'm going to use that as my base image. But then what I'm going to do is I'm going to use GitHub to rapidly develop my app, right? Because I don't want to just do Docker push. Sure, I can do Docker push every time I just, if you already have a CI/CD pipeline that the artifacts of which are a Docker image, that's awesome, right? Just have an app. But for most people, they're not going to have some pipeline like that, right? It costs money for most people. GitHub's free. I just want to use something that's free, right? Most people are very cost conscious. So if you want to do something like that, you could still have a custom image. You could still write stuff to the /home directory where your custom content lives and actually have GitHub working with a custom image. It is very confusing at this point, and we would like to explain the developer story slightly better or make things a little bit more cohesive before we start talking about this kind of functionality, right? So that's why sort of we don't talk about this stuff yet. We're just going to end up confusing a bunch of people saying, wow, what is where, what's going on here? But anyways, we did public preview. We already have a bunch of stuff working. We don't exactly know when our general availability is going to be, but we are working pretty fast on this. We don't want to take too much time. We might just cut down on a few of the features if they're not fully baked out, but we want to ship something early. So there's like is it the build conference that's end of March? I think that's sort of like what we're targeting for. And then we'll add a whole bunch of stuff in there. And we'll see what we get in there working and what we don't, right? One of the things that we don't have working is if people who use Azure App Services, they really love this thing called Easy Auth or the Active Directory integration for authentication. You write 0 code and you get integrated auth with Azure Active Directory or a third-party auth like Google or Facebook working for your app. No code at all, which is amazing. And people really love that feature. So we would need to work on that. We don't have VNet integration yet. So like point-to-site connectivity. So think about things like you have your application in the cloud, but then I have a database which has really confidential information, and I'm moving that data to the cloud, right? So I want my web app in the cloud to talk to a database that's locally on-premise. You can actually do that right now in web apps, the regular web apps. It's called this thing called VNet point-to-site integration, which is a pretty cool feature, and a lot of our enterprise-y sort of customers use that. And then obviously we'll get a whole bunch of different app stacks as well working. But the most important thing is you guys tell us what else you want to see in here, right? For GA, what's really important for you guys, right? And for that, I'm guessing a lot of people want to know how to engage. The best place is just on our forums. So if you just like go to your favorite search engine, type in Azure App Service forums, you'll find our forums. Go post something on there. There's a whole, and it's not like we have some people in service, like some customer support or something looking at this stuff. All the engineering folks on our team are required to go look at the forums for their areas, right? So we have all the engineers monitoring the forum, so we look at the stuff, right? If you don't like our forums because the UI is too clunky or whatever, you can just go to Stack Overflow. Just make sure you tag it with the Azure-web-sites, and the same thing, our engineers will take a look at it. Nothing works out. We have a bunch of documentation already out. At the bottom of the documentation, you can just put comments, and we actually go monitor all those comments. And so we just get back to you on the comments. Nothing else works, just tweet at me at Nazim Lala, so that'll catch my attention as well. So like, for example, if you go to the documentation, Azure App Service on Linux, I'll search for that before. Oh, slides. Jeez, one of these days I'll learn how to do that. Okay. So like, this is like one of our documentation that's already up. We already have documentation on how to use all this stuff. And you can kind of see that people just like ask comments for everything. Like all the questions that you guys want to have, People have probably already asked it, and we just respond to it right here. So that's another way for you to go around doing things. The other thing is that like I really haven't had a chance to show. I want to let you guys ask some questions. We only have like 10 minutes left. But for those people who don't really care too much about using like the Azure Management Portal, we have a Node.js cross-plat CLI. So if you have your Mac or Linux workbook, whatever, it's pretty easy. I have a documentation already up for that. Unfortunately, I think my pull request got rejected because I had some formatting errors or whatever. Our doc guys are like you have slight formatting errors, and they're like, your pull request rejected. So I got my pull request rejected. I need to go fix all those errors, and hopefully in a day or so, those documentations will show up. But it's pretty easy. It's just a npm package that you had to pull down. Actually, 2 of them. So you've got to pull down an npm package and go and update one. Geez, okay, where is it? It's called. I just did it today morning. So this one, node modules. Yeah, so if you just go, it's pretty easy to use. Azure account list. I was using a subscription called Antares Demo, I believe. It's pretty simple to use. Is that not Antares Demo? What is it called? Oh, I forgot. Azure account set. Azure group show Ignite New Zealand. I believe this is. I don't know the syntax for all this stuff, but it's pretty easy. Like the syntax and the stuff is like it's pretty easy. If you get lost, all you have to do is like, oh, that actually works. So anything you don't know how to use, you just do Azure group -- help. I believe. Yeah, that's it. And it shows you all the options you can use. And so you can kind of go see like Azure App Service Plan and Web Apps. So like Azure Web App. And I think you just do -H as well. Yeah, look at that. So you can do all the stuff. There's a bunch of stuff you can do here. We actually have a push. So all that cool custom image stuff that I was showing you, even though we probably won't enable it in the portal UI for a while, it probably show up in the CLI even before that. Because most people who use the CLI are slightly more advanced. So this is CLI. If you don't like the portal, you can use this to do whatever you want as well. And the documentation should be updated pretty quickly on this stuff as well. Come on. Wrong button. Cancel. No. Jeez. I don't know what I pressed there. Okay. All right. Evaluations. Make sure you go fill out the evaluations for the stuff. It gives presenters good feedback, and I know you guys don't care about that. You guys care about the swag, so go fill it out anyways. You get a chance to win an Xbox One S or Surface Pro. Pretty cool stuff. So yeah, we have a couple of minutes. Just questions. What do you guys want to ask? We do not have free or shared. This is dedicated only. The reason this is dedicated only is because of the way we use Docker currently. So one of the caveats with the Docker custom images, I should tell you that right now, is that we run the Docker containers as a non-root user. All right, doesn't run as your root. Because we haven't figured out the security implications correctly, right, at this point. We have all this user namespace remapping stuff we're working on, but it doesn't work exactly well. So because it runs as non-root, there are a few issues, right? So if you have a container, an image, that you build that listens on port 80, guess what? It's not going to work, right? Because listening on port 80 requires root privileges. So you need to go figure out stuff, a few things like that. But the Docker logs that I was showing you is going to really help you out, because it'll basically tell you, hey, your Docker image, it failed to start up in a container because of this, right? And so people mess up stuff like that. They try to write to like the /user directory or something like that. Also, it requires root privileges. So things of that nature, you just need to work around a little bit. That's the other reason we aren't showing this in the portal yet. Hopefully, you should start seeing this stuff in the portal pretty soon. I'm hoping by the Connect conference timeframe, which is like November 16th. And at that point, hopefully, we get all this stuff running as non-root. Running as root. So your container images launch as root. So everything should just work at that point. But because of all that stuff, we don't do free or shared, because that basically means I have these multiple containers that I'm launching from completely different users on the same VM, and we need to make sure the isolation and the sandboxing works correctly, because we have a pretty cool sandbox that we wrote for Windows. We have our own drivers and stuff that does a bunch of sandboxing. We just don't have all that stuff. Docker kind of gives you some of the functionality. I mean, it lets you do C groups. It lets you do app armor profiles. But all this stuff is not really hardened, to be honest. There's a lot of leaks they have in sort of like, even like when they have like namespace remapping and sort of like kernel memory usage is shared across all these things. So like, remember that those Linux ones I was talking about, like the copy and write vulnerability that was like last week? Guess what? If you did free tier, you'd be owned, right? You'd have free guys that would just be like partying on each other's apps and screwing around with each other's apps. It's like, we don't want to get there yet, so no free or shared tiers yet. Any questions? Yes? So orchestration, right? It's an interesting question. So for orchestration, so the problem is that we have a couple of services already, right? So there's one called Azure Container Service, ACS, that does orchestration. And I believe it's built on Mesos. It is built on Mesos, yeah. So it's using Mesosphere under the covers, right? So if you want to do some cool orchestration stuff, that's the way to go. But the way it really works is that it'll just spin up a bunch of VMs, like I think 5 VMs minimum, with all the application stack and everything installed on it, and just say, here you go, it's all yours, right? It's pretty much like you're managing a bunch of VMs with stuff pre-installed. So it's not fully managed. But if you want that kind of control, ACS is the way to go. Will we make that story easier? I'm not sure at this point, right? It's conceptually, could be done, right? I mean, I already talked about this thing called Azure App Service Plan, right? Which is sort of a container which you can have multiple images in, right? And all those apps are getting loaded on the same VM. So all I really need from you guys is some network configuration on how to configure the overlay network and a bunch of other metadata stuff, and boom, we can just do orchestration for you as well, right? And we can even expose some config that says, yeah, I have a large VM. What percentage of CPU and memory do you want to give each one of these containers? So you can do a lot of this stuff, but we're not sure if you're going to focus on that right now. I mean, we have other things that we should probably do better, like giving better logs and not showing 503s every time we go recycle your app. So we'll fix a bunch of stuff like that first before we try to do things like orchestration. It's a fair question, though. Any other questions? I'll just hang around here outside, so if you guys have some questions that you're shy to ask in front of everyone else, you can just ping me over there. Cool, well, thanks a lot, guys, for attending. Hope you guys have a really great time here at New Zealand. So, cool. Thanks.